Right. Let's get on with the last module and then we are done with maths. Right there by the finish line, Kaya. Right? You can see it. You hit that bell when you're coming to the stadium. You can see it right there. Okay, so yeah, he needs to come back now.
Yeah, but there's a rubber there. There's a rubber very one. Couldn't exam. You need to get through it.
It's either you push it or he pushes you.
Yeah.
Okay, I'm on page 243. Okay, so integration has two meanings, and you're going to be using these two meanings for the sections. Okay, so the first meaning is summation, which we will deal with later. Second meaning is that integration is the inverse operation of differentiation. So there are two meanings. One is summation, which we're going to deal with later. Okay. And for now, you need to know that integration is the inverse operation of differentiation. So it's basically like the opposite of differentiation. So you see that sign that they gave you over there. It looks like this. Okay? That sign basically means to integrate. Now you're getting used to the words that we use. Like how for derivative dy over dx, that's the words that we would use, the prime or that sort of things. Integration looks like that. So that sign means to integrate. That sign with dx means you're integrating with respect to x. Remember like how before we were differentiating with respect to x, now we're integrating with respect to x. Meaning that your answer should have terms of x in it. Okay? Integrating dy means that you should integrate to y. And then if you have x squared dx, it means that you are integrating that function of x squared with respect to x. So when you're integrating x squared, your terms that you end up with should be x. Okay, it seems like a lot, but it's not. Okay, I'm on page 244. Now, remember with differentiation we had rules. Okay? Like how we had the derivative of x to the power n. Right? That was equal to n times x to the power n minus 1. Remember? Mm-hmm. Now we got integration rules. Now integration rule says that the integral of x to the power n dx is equal to x to the power n plus 1 all over n plus 1 plus c. Now c is a constant. Okay, I'm going to do an example now, and you must write that c every time you integrate. Everything that you integrate, you will always have a function of c. It's very important, okay? You will always have something plus c. Whatever you integrate is plus c. So let's do an example of what they're talking about here, right? Okay, let's integrate. Integrating x to the power 5 with respect to x. Now if you look at this, it looks like that standard integral they gave you, right? The integral of x to the power n. Okay? Now that basically says that it's x to the power n plus 1 all over n plus 1, so n in this case is 5 plus a constant. Okay? Am I got it? Got it? Okay. So this is x to the power 6 over 6 plus the constant, which is 1 over 6 x to the 6 plus your constant. And that is integrating that. I basically just use the rule, and don't forget the constant value of c. We don't know that number because, let me show you why, right? Remember we said that integration is the inverse of differentiation. So if I had to differentiate how would you differentiate this? You would differentiate 1 over 6 x to the power 6 plus d over dx times a constant. Right? This is a constant, so you take it out. 1 over 6 d over dx times x to the 6 plus the derivative of a constant
0.
is 0. So, you got 1 over 6. Differentiate this. If I multiply this and this, it's going to cancel that. And see what we started with there? Okay? So, it's basically the opposite of differentiating. So, if you differentiate something, if you're given a function, and if you differentiate it, to get it back into that function, you integrate it. Okay? Cool? So all I did over here was, for this part here, was I was given a rule, like how we did differentiation. I looked at this question, I said, okay, it looks like that rule that has x to the power n, and I applied the rule. This is just a test to show that if I differentiate this, you should come back to the same thing. Okay? Apply the rule. Please don't forget the constants. Let's do another example.
Okay, but
The second to last bit, the x6 over 6. What you did there?
5 plus 1.
No? The last one, the answer?
Yeah,
Yeah.
it's 1 over 6. Same. Remember, if I multiply this into this, it's x6, yeah.
Same.
Right now, yeah, I'm writing my.
No.
no, you missed. It's like you missed a
It's
step.
like
That's
this.
why. Yeah.
But it's fine. Did I get it?
Hmm?
You get it?
There we go.
Okay. So, let's do another example, right? If I had to ask you all to integrate
Yeah.
dx, how do we integrate dx? Because that means integrate with respect to x. Integrate what with respect to x? 1. But what is 1? X to the power? No. Okay, not okay. No, 1 is a constant, right?
Yeah.
But what is 1 also?
X to the power 0.
Okay, so you're basically integrating x to the power 0, which would be what? This would be, now if you apply the rule, your end value is,
In plus 1.
because remember the difference here is being backwards now. Imagine that your function was 1, right? You derived something, you came up with 1, you used it. Now I want to integrate to get it back into the equation. Okay? So, this is going to become x to the power 0 plus 1 all over 0 plus 1 plus the constant. Don't ever forget this constant, otherwise your integration means nothing. Okay? You end up with x plus c, because x to the power 1 over 1. That's what you end up with. Okay? So another example, let's do 3x.
Yeah, do a little bit of a more complicated one. So
Yeah.
Yeah.
Okay, so let's do integrating 3x to the 4 dx. Okay, this is a constant. So what you do with the constant is you take your constant out and you just integrate that portion. Remember, it's a constant being multiplied to a function. Like how we did derivatives. If I say you derive 3x to the 4, you take out the 3, you derive x to the 4, and then you multiply 2 the 3. Same story here. Okay? So, this here would be 3 integrating x to the 4 dx. Okay? So, this is 3 times. So, x to the 4 is x to the 4 plus 1 all over
4 plus 1
plus c. The only difference with this is that you don't multiply the 3 to the constant, right? You only multiply to the first part. You don't say 3c or something like that.
Because C is a constant.
C is a constant. C could be any number, okay? You just keep your constants together, because when you're differentiating your constants, what will happen to it? It will disappear, okay? We don't know what the original equation was for you to put a number to that constant, but we're just integrating to do the inverse of differentiating, okay? So, this would end up becoming 3 times x to the power 5 all over 5 plus a constant, which is 3 over 5 x to the 5 plus. You understand what I did there?
Yeah.
All this is so far, I'm just applying that rule. Do I have any other examples? Yes, I do. Okay. Oh, sorry. So you see on page 245, right? The other rule when he said integrating kx to the power n.
Yeah.
Yeah.
That's the rule that applies to this example. I don't know why I did the example. I forgot that there was a rule sheet, right? But that's the rule that applies to this example. Okay, you're all with me, right? Same thing over here. They said integrating k times x to the power n. They took k out and they integrated x to the power n. Okay, I'll see that, right?
Yeah.
Okay. Then,
Also, it can't be equal to -1 because then it'll cancel out.
which one?
It says the n can't be equal to -1 because then it'll cancel out.
Yeah, you're gonna end up with x to the power 0.
Yeah, which would, okay. Right.
Okay?
Yeah.
Maybe you see can't be equal to -1.
So the same thing.
Make k is equal to a constant.
Yeah. Kx n,
Yeah.
not real. N is not equal to -1.
Where?
On top, man, on the front there. Objectives and overview.
Oh, you're looking there. I'm looking at the other example.
Not the example, I'm saying the rule.
Yeah, no, I'm looking at page 245.
Yeah, I know.
With the top there. I thought you were reading there.
Oh, no.
But that's where the rule is I'm talking about, right?
Yeah, no, I'm just saying, but that's what it says here.
Yeah, because
Can't
it's
be one,
gonna,
cancel
you're not
out.
gonna get you're not integrating like
Yeah.
after that.
Yeah.
Okay?
Okay.
The other rule they tell you is if you got a function being added or subtracted by a function. Okay? You see f of x plus minus g of x? You integrate each function. So remember like with the derivative, when I add d over d, lasted so long. D over dx of 3x plus 2x, okay, say 3x squared plus 2x, right? You remember you derive each function, but we skipped it after a while because we got used to it, right? Same story over here, but now you're integrating two functions that's being added or subtracted. So what do? You integrate each function. So if the example says integrate x cubed plus x squared minus x with respect to x, how you would do this? You would integrate x cubed with respect to x plus x squared with respect to x minus x with respect to x. With me?
Okay.
Anybody confused? Fine, right? So now you'll apply your rule because this looks exactly like the first rule, which is x to the power and integrating x to the power n dx. Okay? So this would become x to the power 3 plus 1 all over 3 plus 1. Now another thing with the constant, when you have terms like this, you just need to add one constant at the end. That one constant will cover all the values. Okay? So I'm going to carry on with this. I'm going to say plus x to the power 2 plus 1 all over 2 plus 1 minus x to the power 1 plus 1 all over 1 plus 1 plus c. Okay, that constant covers the constants for each one of these things. Okay, you're not going to say 3c or 2c or something like that, it's just a constant. Okay, then you end up with x to the power 4 over 4 plus x to the power 3 over 3 plus x minus x to the 2 over 2 plus your constant. You can say quarter x to the 4 plus 1 over 3 by the time. That's how you integrate it using that rule. It's not difficult, right? It's a rule given to us. I'm basically just using the rule. Okay? Right. Now, on page 246, that's your important thing. Right? You know like how we had the rule 1 to 25 for differentiation. This is your rule 1 to 21 of integration. Okay? Basically, all are the opposite of derivatives. Right? So, on page 246, summary of all the relevant standard integrals. Please highlight that, asterisk it. I don't know, put important or something like that, but that's your important thing you need to know for this part, right? And I'm going to do examples. Yeah, highlight that example.
Which one?
Summary of all the
7.3.
relevant standard integrals. Yeah, 7.3, page 245, right? The nice thing about this integral part, they actually ended up doing an example of all the rules for 1 to 13. So that means I'm going to do examples for all the rules from 1 to 13. We'll take out a picture of this first before we... Okay, so let's do it, right? And once we finish, when I finish doing the examples for all these rules, we're halfway through integration.
So would they ever like give us like a graph or something and have to work backwards?
No, but you do use graphs in this one. Because you integrate to calculate the area under a curve. The drawing, we come. That is.
I just thought if you go one way, then you could be able to ask that.
Go back the other way. Yeah. Okay. Okay. Now I'm doing all the examples that's on 247 and so on, right? So I'm gonna do more examples. It's basically this example here is 3x to the 4 dx. I'm integrating 3x to the 4 with respect to x. Okay? So first thing you would do is you would take out your constant. And which rule is that? That is rule number 2. Okay? Now I'm going to integrate that. So this is going to be 3 times x to the 4 plus 1 all over 4 plus 1 plus c. Not put the black inside, right? Okay, I think the multiply, right? This is rule 1. So this is 3 times x to the 5 all over 5 plus c, which is 3 over 5 x to the 5 plus. I understand that? Anybody's confused? Good. Another example. They tell you integrate 1 over x squared with respect to x. X cubed. They never told you x squared. Right. 1 over x cubed with respect to x. So, how would you do this? You would integrate x to the power minus 3 dx. Because remember 1 over, we take it to the top, it's x to the power negative 3. Now you would use, okay, so you would integrate, right? You're left with x to the minus 3 plus 1 all over minus 3 plus 1 plus c. This is rule number 1. So you're left with x to the power negative 2 all over negative 2 plus c, which is minus 1 over 2x squared plus c. Okay, there, because the x squared will come down and the 2 will be there. So it's minus 1 over 2x squared. Y'all get that there? Okay. Let's do another example. This is the same shot that got missed the last time with the marker. That thing never come out. Right. What we integrating? 3x?
3x squared plus
Yeah.
6.
Plus 6 with respect to x. Right? Which rule does that look like? Rule number 4. Where you got f of x plus minus g of x. So what would we do there? You will integrate each one. So this would be the integral of 3x squared with respect to x plus the integral of 6 with respect to x. This is rule number 4. So you would take out your constants, right? This is 3 into x squared dx plus 6 integral of dx. That will be right? Yeah. This is rule number 2. So this would be 3 times x to the 2 plus 1 all over 2 plus 1 plus 6 times. Remember when we did the one where we had x to the power 0?
Yes.
Same thing. Integral of dx. Oh, remember that, right?
Yeah.
That now. Okay, so this is x to the power 0 plus 1 all over 0 plus 1 plus the constant. Okay, so this becomes 3 times x cubed all over 3 plus 6x plus c. Cancel, cancel. X cubed plus 6x plus. With me? Anybody confused? Fine. Okay, so this here is rule 1. Another example. 10. It's another example, right? It's gonna be x plus 2 plus 3 over x squared, right? Integrating x plus 2 value
Plus 3 over x squared.
plus 3 over x squared with respect to x. Okay? So rule 4 again, right? Because it's a function plus function plus a function. Okay? So it will be the integral of x with respect to x plus integral of 2 with respect to x plus integral of 3, I will say x to the minus 2. Okay? With respect to x. And we integrate, okay? So this here will be x to the power 1 plus 1 over 1 plus 1 plus 2 times x to the power 0 plus 1 all over, all with me there, okay, plus 3 times x to the power minus 2 plus 1 all over minus 2 plus 1 plus c. All with me there. Okay. X squared over 2 plus 2x, well it's just 2x, right? Plus 3x to the minus 1 all over minus 1 plus c, which is, let's say, half x squared plus 2x minus 3 over x plus c. Do we all understand?
Yes.
Anybody confused? All together, right? Simple, you just be applying the rules. Right? Oh god, I got the board face again now.
No.
You're fine, right?
Thinking base.
Okay. So thinking
It's
base.
the first time to absorb.
Okay. Okay, can I take out this one?
Yeah.
How are you going to change it?
10 to 11.
Okay. Guys, almost there, right? Let's integrate that. Okay, it's a function plus a function. First, right? Let's do that. So this here is the integral of the square root of x with respect to x plus the integral of square root of 2x with respect to x. Right? This here is the integral of x to the power dx, right? Plus, see this here is the same thing as saying the square root of 2 times the square root of x. Okay, because both are under the same sign when you're multiplying it, right? Because remember, if you have square root of 2, times the square root of 3 is what? Square root of 6. You know that, right? You're going to put in your calculator too, right? You're going to come to the same thing. So it's the same thing there. I'm just separating what's being multiplied. So this would be root 2 will come out as a constant. Yes? Integral of x to the power. So write all the steps.
Yes, please.
Okay. So here is integrating root 2 times root x dx, right? Then it would be, I'll take out the constant, integrating, and then square root of x is x to the, okay? Everybody's with me, right? So this way is integrating x to the half dx, right? Now this all looks like x to the power n, right? So this would be x to the power half plus 1 all over half plus 1 plus square root of 2 times x to the power half plus 1 all over half plus 1 plus c, right? This is x to the power 3 over 2 all over 3 over 2, 1 half, right? Plus square root times x to the power 3 over 2 all over, okay? This here is a fraction over a fraction. So this becomes 2 x to the power 3 over 2, oh yeah, 2 over 3, right? With me? Okay. Plus, this will also be root 2 times 2 over 3 x to the power plus c. Everybody is with me? Anybody confused?
Why square root of 2? We don't say 2 to the power half.
I'm going to do that.
Okay.
Okay? Then this method for the math here is a bit, let me just also check what I did today. You have to do. What did I do? Okay, right. So I'm gonna change it here as 2 to the power half, right? So this is 2 to the power half, right? That's fine, right? Okay. Now, so this is 2 over 3 x to the power 3 over 2 plus. See this 2 to the half times 2, right? Because all of that will be 2 to the half times 2 all over 3. Right? If you have same bases, what do you do to the indices? Remember this here is 2 to the half times 2 all over 3. Okay? Same bases, this is 2 to the power 1. Same bases being multiplied, you add the indices. Okay? So this is 2 to the power 3 over 2 times x to the power 3 over 2 all over 3. You with me? Can you see that? Right? Because 2 to the power half times 2 is 2 to the power 3 over 2. X to the power 3 over 2 is here. All that is being divided by 3. With me, right? Yes? Then all I'm going to do now is bring my surds back. That's square root set. So this here becomes 2 over 3 square root of x cubed. Fine with that? Plus 1 over 3 square root of 2x cubed plus c. this here is not integration problem. This is more of maths, like with surds and stuff, right? Okay, do you understand how I got to my answer?
Yes.
Do you understand like the method I used in each one? Okay? So once I came here, remember for a surd, right? For this here, it's x to the power 1 and this here is a 2. So when you're converting it, it's x to the power 1 over 2. So if x is to the power 3 over 2, when you're converting it into a surd, it's going to become, the denominator will tell you what surd it is, and it's x to the power 3. That's how I did it here. And because these two are to the same powers, I can put them as being multiplied under the surd. Okay, yeah, take a picture of this one. Let's do another example, okay? You're gonna hate me at the end of this one. It's okay. When you get your info certificates, you can love me. Then you come in February, you'll hate me again.
Does it get more complicated than this?
What?
This slide.
Now?
Yeah.
Okay. No, this is not complicated, it's just the math that was
I'm not saying
involved
it
in
gets
it.
more complicated than this because I think if you follow the rules, it actually doesn't seem.
Oh, you mean like, no, it's not bad. Integration is not bad at all.
If
Okay?
you follow the rules,
They give you the rules,
Yeah,
so
actually
it's
easy.
okay. Right? Can you take this up?
Yeah.
It's just the main thing is you need to go home and practice using the rules. Like you see now we did 5 examples. And if I ask you to integrate x to the power n, how you do it? You all remember it, right?
Yeah.
And there was only from 5 examples. Now imagine if you do more examples using these rules, it gets stuck in your head. If you derive x to the power n, it's n times x to the power n minus 1. If you integrate x to the power n, it's x to the power n plus 1 all over n plus 1 plus c.
Can we do something with the other rules? Because
Yeah, I'm coming to that.
Because the trig ones are.
Yeah, I'm gonna come to that one just now, right? Okay, so far rule 1, 2, 4, cool? Yeah, no stories there? Right. Now I'm doing page 250, integrals of trigonometric functions, right? It's the same rules that's in your, if you turn back to page 246, right? It's the same rules as 10, 11, 12 and 13. Okay, actually it's just 10 and 12, right? See the sin x, same thing as the other one, cos x. They just, what they did over here was, I don't know why they broke it up into specific sections on each thing. But regardless, it's not a problem, right? And then they tell you that although the following integrals are not specified in the syllabus, they follow very easily from differentiation, right? Integral of sec squared x is tan x plus a constant. Remember the derivative of tan x is sec squared x. So the integral, which is the opposite, should bring you back to tan x plus a constant. It's all the opposites, right? Especially for trig functions. If you remember how to derive, the opposite is true for integration plus a constant. Right? If I ask you to give me the integral, derive cos. What's cos? Derivative of cos?
Sine.
Minus sine. Right? So the integral of minus sine would be cos. Same like how they got over here. See like how they got integral of sine is minus cos. Okay? You're getting it? Okay. Let's do an example here, right? So, the example is integral of 3 sine x plus 2 cos x dx. You'll never even help me finish the question, nothing, yeah? You turn around 10 times I must turn around. Right. There's a function plus a function, right? So first thing you integrate each one. So you'll integrate 3 sine x dx plus 2 cos x dx. Take out your constant. 3 sine x dx plus 2 so this will become what? 3 times, what's the integral of sine x? Minus cos x plus 2 times the integral of cos x. Not bad. We use rule 1, rule 4, rule 4, not even rule 1, rule 4, rule 2, and then the sine rule 10, I think. Okay? Let's see if I should it's dark. Then let's do another example where they say integrate. You can see this, huh?
Yes.
Okay. This is 4 cos x.
Minus 2 sec squared.
Thank you. With respect to x, right? Function plus a function. You integrate 4 cos x dx minus 2 sec squared x dx. Take out your constant. 4 integral of cos x dx minus 2 integral of sec squared x dx. Right? No, I never integrated yet. Only when you integrate, only when you get rid of this, then you'll add the constant because it means you integrated. Okay? So this would be 4 times cos x is minus 2 times sec squared x plus c. So you're left with 4 sine x minus 2 tan x plus c. Still not bad. Okay, that was using trig. Now look at integrals of 1 over x, e to the power x, and a to the power x. A to the power x, remember, is the 2 to the power x or 3 to the power x. It's a value to the power x, right? So how would you do those? They give you the rules for the integration, right? They give you how they got to the rules. Remember how you would have got to the rule is you derive whatever that is and see if it gives you what you're integrating, right? So let's do some examples of that. Let's do the example that's right in the bottom where they say integrate, what do you integrate?
Which one to my example?
251 right in the bottom.
3e to the power, oh my god. Let me see, try to see x.
X plus 2 to the x.
Plus 2 to the x, yeah.
Plus,
Minus 3 over x.
okay, dx. So now we're looking at rule number, this would be on page 246, this would be rule number 6, 7, 8, okay, say 6, 8, and 5. 5, 6, 8, right? Because we go again when we do constants, but it's all the same method. You just
2 to the power x is
not 2x, 2 to the power x. Sure. Right? Now, function plus a function plus a function. Integrate each function. Right? So this would be the integral of 3e to the x dx plus integral of 2x dx minus integral of 3x dx. Pull out your constants. 3 e to the x dx plus 2x dx, because remember this is a to the power x minus 3 into 1 over x dx. Yes? Integral of e to the x is e to the x.
It's the I to the x.
It's e to the x. Check the rules, right? Plus the integral of 2 to the x, so that's a to the x. What does the rule for a to the x state? So it will be 2 to the x over ln of 2, right? Minus 3 times integral of 1 over x.
ln of x.
Ln of x. Confidence, guys. Plus c. So this becomes 3e to the x plus 2x over ln of 2 minus 3 ln of x plus c. So now this is us making use of the other rules as well. Okay? Your
Okay, so we're still going back to the differentiation rules.
for which one?
These are.
The integral rules. Yeah. Remember I told you that the way they did this section was they gave you all the rules and then they like basically gave you examples on each set of rules. So we covered like rule 1, 2 and 4 in the first set of examples. Then when we came here, we did some on the trig rules. Then now we did some on your e to the x, a to the x and 1 over x rules. Okay? More examples that we can do is this. Then this. Okay. You integrating 1 over 3x plus 3 over sec x dx. How would you integrate that? Function plus a function, you integrate with 5. Integrating 1 over 3x dx plus 3 over sec x dx. Right? Then this would be 1 over 3 into 1 over x dx. Do we all agree on this?
Yeah.
Okay, I'll pull out the constant, right? Plus 3 into 1 over sec x dx. But before I carry on, what is 1 over sec x?
It's cos.
Cos, right? Because remember sec is equal to 1 over cos. This would be 1 over 1 over cos, which is cos, right? So this is 1 over 3 integral of 1 over x dx plus 3 into cos x dx. So some of your trig rules came into play here. Okay? This is 1 over 3 times, what's the integral of 1 over x? Ln of x plus 3 times the derivative of integral of cos x is sin x, right? It's from the rules that's on the page. Exactly like how we do differentiation. You go to your rule, if you make it look like how that looks, you use the rule, you come back and substitute it, right? Sin x plus c. So this here is 1 over 3 ln of x plus 3 sin x plus. You understand? Okay, let's do another example. Because we love doing examples. Right? This one here is 2 into 1 plus cot squared x times sine squared x dx. I want you to integrate that. How would you do it? It's not a function plus a function plus a function. These are being multiplied. So, 1 plus cot squared x is what? Go back to your trig, that important formula page, and go to your important formulas on the important page. Cosec squared, right? So, from your trig rules, I'm pulling up this constant, right? Integral of cosec squared x times sine squared x dx. Do you understand our cosec squared x? From your trig rules, right? So when you go back to your trig rules, under important formula, you're going to see 1 plus cot squared x is equal to cosec squared x. You need to know trig laws as well, but you're going to know that for the paper. 2 integral of cosec is what?
Over sine.
So this will be 1 over sine squared x. You understand that? Times sine squared x dx. Cancel, cancel. You are integrating dx, which we know is x, because it will be 2 times x to the power 0 plus 1 all over 0 plus 1, which is plus. So from the start and what we got, I never would have thought that, huh? Integrating 2 into 1 plus cot squared and you end up with 2x. So trig always sneaks up, it finds its way. Some way, somehow it finds its way.
I think I prefer it. You know, in school, let's keep it separate.
Yeah, you
Now
just
now
each
it's,
section, yeah.
Let's keep it, gets it like that.
Now it's everywhere. But guys, do you understand what we're doing so far?
Yes.
Is integration difficult? You're just taking your rules and you're applying it. It's just that you need to do a lot of examples. So when you come to questions like that 2 into 1 plus cot, you know, use the trig laws. When you come to even like these ones here, 1 over sec, you'll remember your trig rule where it will become cos. Things like that. It's all the stuff you need to remember, right? Now I am on page 253. Integrals of the trigonometric function if the angle is being multiplied by a constant. So you see for this one here, sine of x was being multiplied by the constant. Agreed? For this first one that's in black writing here. 3 sine x was constant sine x. What happens if you have sine of 2x? Now your constant is being multiplied by your constant is being multiplied by the angle. In derivatives, we would have said function of a function. You understand what I'm saying, right? So, this is different. So how would you do this? There's a rule for it. I can't take it. Okay? There's a rule for it, and that rule is on page 273, 253. On 253, right? Okay. So, if you were given, example, sine of 2x dx. This is not 2 sine x, this is sine of 2x. In derivatives, we would have said it's a function of a function. One function is sine of the bracket, and 2x is your other function. But now this is same thing, right? The rule says that integral of sine of kx dx is equal to sine of I'm sorry, minus cos kx all over k. So what would this become? Minus cos of 2x all over 2. No. I just use the rule, right? My k value is 2. So I just substitute 2 wherever I see the formula. Okay? So you could have also said minus half cos 2x plus c. Fine?
Yeah.
Please don't go bored on me. I know this is too easy for you, but we have to teach it, guys. We have to teach it for the syllabus, right? Then, if they gave you cos pi x dx, now pi is a constant, right? Pi is 3,14. So it's the exact same method, right? You would apply the rule, what the rule states, for cos kx.
Okay.
Remember, this is cos of k times x. Pi is a constant.
Yeah, so it's
Okay.
Minus,
So
it's minus
Not positive sign.
derivatives is minus sign. Derivative of cos is minus sign. So this is sine
KX.
pi x. So k would be pi right over pi plus c. Cool? Okay. Then see if you have
No, because minus. Because minus sign.
no, it's not.
No.
The derivative of cos is minus sine. The integral of cos is sine.
Yeah,
Yeah.
the opposite.
No.
Okay. That's what you give it. Right? Your constants in this instance is your b and your a. Right? The b is being multiplied by x, your a is being multiplied by x. This is a function plus a function. So you integrate each one separately. So this is the integral of 2 sine b plus x, no man,
X plus
bx plus c plus dx plus integral of 3 cos ax dx. Right?
Okay.
Pull out your constants. 2 integral of sine bx plus c dx plus 3 cos ax dx. All will be. Okay? So this would become, from your rules, right? 2 times minus cos bx plus c all over b plus 3 times sine ax all over a plus c. All still with me? Minus 2 cos bx plus c all over b plus 3 sine ax over a plus c. Anybody confused with that? It's sad when you go quiet here, make me worried. You're bored, you're too bored. Isn't
No, make no sense of.
it? I need to start giving you other stuff. It's too easy here. I can take this up.
Yeah.
After your marks for the test 2A, the department is gonna think, hey, this boy needs to go teach everywhere in South Africa. I'll say yes.
You want a trumpet or something?
Okay, let's do one more example, just to make sure it's there. Cemented. Okay, we are now. What are we doing that? What were you doing? It was sec cubed. Lost my pages.
Sec 3x. 3.
Yeah, sec. Yeah. Sec. This one is the integral of
Sec 3x
times
times 10 3x. Oh, x. Yeah.
10 dx, huh?
Yeah.
Right. Do it.
Okay. Integral of sec dx.
It is
Integration rules.
Sec x.
Check the integration rules.
Sec x.
What's the integral on your integration rules of sec kx times, it'll be on page
No, number 5.
number 5 on page 250, right? Sec x tan x, right? The same thing with the constants we know now, you just divide by the constant, right? It's gonna bring this to sec 3x all over 3 plus c. Because sec x times tan x gives you sec x, right? We've learned with the constant rules, all you do is you divide by the constant. Whatever that would have came to, you just divide by the constant. That's how they get that.
Where is that? Roll number?
Page 250, rule number 5, right? It's not with the constant, but remember with the constants, you just divide by k. You understand what I'm saying, right? You just divide by k. Cool? Everybody's okay with that? Right. Let's do. Does your page 254 also get repeated?
Yeah. True.
Yeah. Okay. But remember we did integrals of e to the x and a to the x and 1 over x. Right? Now let's do for bottom of page 254. Let's do for e to the kx, so e to the power constant times x plus and a to the power kx. Guys, you're all with me, right? Okay. So say we gave you. Where's my example? Say we gave you 2 to the power 3x dx. Right? So on bottom of page 254, you'll find the rule for e to the power kx. Now if you're looking at this, this is a to the power kx. So what's the rule for the integral of a to the power kx? It'll be in the bottom of page 254.
No, Simon.
No, I like it. It's at the top of page 255.
A over A.
Okay. And then K.
So it will be a to the power kx all over
Okay.
ln of
A.
just ln of a.
Yeah.
Okay, no,
K.
it's k ln of a. K ln of a, right? So it's 3 ln of 2 plus c. You see all those headings after that summary of formulas, right? When they told you integrals of trigonometric functions, they gave you the trig that they had in that summary. They gave you some for sec, cot, and all that stuff. Then we did the integrals of e to the power x, a to the power x, 1 over x. They have that in our summary of formulae, right? Then we did, now we had integrals of e to the kx and a to the kx. You just notice that they don't like to mention the ones with the constants much. You all need to remember that part. Like you see for the trig one, when they didn't show this in part of our summary of formula, but after we did a few with constants, we realized that all you need to do is take that same thing and just divide it by a constant. Okay? With me? Right. Let's do one more example. E to the minus 3x. Right? So we're integrating e to the minus 3x dx. Right? Look for your rule. E to the power kx
Kx over K.
over k.
That's it.
And that's your so far, guys, with integration, does everybody understand what I did today?
Yeah, I'm following.
All with me, right? Well, all we basically did was we were given rules. We learned how to apply the rules for different sets of questions. We all need to practice these rules because that's the only way you're going to know how to use them is by actually doing examples and doing exercises, and the main thing, past your papers. Would you believe me if I told you that we are halfway through integration? Because you can even see how many pages are left.
And these rules we don't have to know, we don't give us.
They give you most of it later. Sheet, I just need to check which ones
Give
you
us the ones.
need to
Think about the question.
whether it's specifically applicable. But you just need to check, right? Because some the ones that they skip, remember actually it's like maybe they skip the one with the constants, you all just need to remember that's okay, right? Yeah, so tomorrow, hopefully, by God's grace, we finish integration. And then from Wednesday we can start pushing on faster papers. So it's not bad, right? You all remember today we learned that integration has two meanings. It means the summation of something, which we're going to look at tomorrow, and it means the inverse of differentiation, which we looked at today. Today you've seen it in action, right? Any one of these answers that we got for every example I did on integration, right? If you differentiate it, any one of these answers, then you differentiate that, you will come back to the same equation there that was given at the start. Okay, like how I did that first example, I integrated it, and remember I differentiated it came back to x to the power 5. All of these here you are able to go back to that same equation using differentiation, and that's sort of like a check method for your answer. If you can differentiate it and still come back to the same thing, your integration was perfect. Okay, so any questions on what we covered? Is everybody okay? Almost there? Kaya, now you can smell the finish line now.
Hey, I can hear the people.
You can hear the people screaming. You can see the cameras flashing.